since I started working there. And I'm going to talk about the Docker Content Trust feature and kind of some of the technologies that went into making it happen. I don't know if we're supposed to do audience interaction, but how many people here have used Docker before? Only a handful. All right, I'm going to do a quick crash course on Docker. I'm going to talk about Docker in 5 minutes when I usually talk about it for about 6 hours. So Docker, of course, is a way to run processes in containers, and its big value add is I can easily create a container, and as far as that process is concerned, it's in a certain environment with a certain file system with certain things about that environment, and I can move that around to different places, and from the process's point of view, it works the same. So I can go from my laptop to a server to a desktop to a dev server, and the thing running in the container, it works pretty much the same, and that's a huge value add. But the security part of that comes into play because you're moving around big files that could potentially have been tampered with at some point, which is where the Docker Content Trust feature comes in. Basically, the motivation behind the Content Trust feature was to provide some guarantees to these things that you download to run in Docker, the Docker images. And it uses a specification called the update framework, which is a generic specification for a way to build a secure software updater. And we'll talk a little bit about TUF and how that flows in. We use a project called Notary, which was created at Docker, which is an implementation of TUF. And the Docker Content Trust feature itself utilizes Notary. Notary is generic enough, you can take it and do other cool stuff. And I've seen some hack day type projects out in the wild with Notary, even though it's a few months old. And it's actually really cool. So the first question that comes up to a lot of people that are in the know about package signing and stuff when we talk about the Content Trust feature is, well, why didn't you just use GPG? And I'll be honest, I was in that camp before I learned about TUF and what it was and what it brought to the table. I'm an Arch Linux user. If I do my pacman install, the Arch maintainers have signed all their packages, and I can do a GPG signature verification, and boom, I know that this package came from the publisher, and that's good. I also use GPG in my own email, so if I send you an email, I can sign it, and you know, hey, this email that Jeff sent 5 years ago really did come from him, assuming that the key is still not compromised, which I hope mine isn't. But there's a couple of things that GPG doesn't do that well when it comes to when it comes to software updaters. If I'm installing a package and I install, going again to the 5-year time period, if I install an old version of OpenSSL, I might be installing Heartbleed, but that package was signed by the maintainer, and that package has not been tampered with since it was last published. So there's a need, just because of that, for there to be some other guarantees around this package that goes beyond just a simple signature. There's also the problem of getting public keys from your maintainers or your publishers out to your users, and how do you know that those keys really are from the proper channels? And some of that burden is going to be on the end user, which is okay for advanced users, but if I'm not an advanced user, I still need to be able to get software updates in a timely manner. So just simple GPG alone isn't everything. So we have to provide some of these other guarantees and things on top of that. So that's kind of what TUF does. Some of the other concerns when you are running a software repository that signing doesn't solve There's a whole list of other attacks that can be done. If I compromise a mirror as an attacker, I could cause that mirror to send just an endless stream of data to someone checking for updates, and that endless data could potentially deny their service. Their server could fill up with RAM and then fall over and die, and that's an attack that could happen that signing alone doesn't solve. Another thing that could happen, and I actually remember having this happen to me with Arch several years ago. The mirror I was using stopped rsyncing, so I was not getting updates. Any package I tried to install was valid signed, but it was 2 weeks or 2 months old or however long it was till I realized I wasn't getting updates anymore. And that was my fault because I didn't configure my mirrors properly, but it happened to me, and it could happen if an attacker compromises a mirror. They could just force you to stay on your old package versions indefinitely and wait for a vulnerability to pop up. You can do rollback attacks, going back to the Heartbleed or the Ghost or any other number of vulnerabilities. I can find an old signed package, insert it into the pipeline, and your installer would just take it and use it potentially. So there's lots and lots of things that we need to protect ourselves against and protect our users against, beyond just simple object verification. And the update framework aims to do that. This is kind of their mission statement. A software update system is secure if it can be sure that it knows about the latest available updates in a timely manner. Any files it downloads are the correct files, and no harm results from checking or downloading files. So I've been kind of talking about some of these concepts already, but the core concepts of TUF are to guarantee freshness. It also talks about online versus offline key security. So for example, if I have my Jenkins server that's publishing my artifacts, I might want to have it do signing for me. So I'm going to have an online key on my Jenkins server, and it signs every time it publishes. And that is very nice for convenience, but if my Jenkins server is compromised, now an attacker can sign content as if they were me, and that's bad. So the solution is to use an offline key. But now I can't do automatic publishing of repositories because my key is in a safe. So there's trade-offs for these key security strategies. So TUF tries to take each strategy and apply those to roles where it makes the most sense. And we'll see a little bit more of that in a little bit. The other concept that TUF has kind of ties back into the freshness. I'm signing a collection, so these are my valid artifacts, maybe the latest LTS release and my stable release. And then if something is no longer valid, maybe there's a vulnerability, I'll take that object out, that version out, and replace it with another version, and then my collection of current stable things has changed. So I'm not just signing one-off objects that are with signatures that are valid forever. The update framework defines these different roles for keys. So for a TUF repository, there's a concept of a root key. So every single key that comes out of this TUF repository will be signed by the root key. The root key is the one that I'm going to want to take and have offline and lock that in a safe. So once I generate my root key, I can generate my snapshot and then target key. And those actually are used and can be semi-online keys. And those are actually used to sign the content. So the root key just signs the signing keys. So it's kind of analogous to a certificate authority, but not really, because there's no certificates involved. And then the timestamp key, that's potentially going to live on the actual reference repository that is accessible on the public. So this timestamp key, its role is to guarantee freshness of the metadata. So anything that is signed by the snapshot and target key, the timestamp key will sign it and say, hey, as of this time, it is valid. And then you want the verifications done by the timestamp key to have a very low expiration, like maybe 5 or 10 minutes. So you can be sure that it's pretty recent. Pretty recent being 10 minutes, I think, is very reasonable. And you can, in any TUF implementation, you can choose how long that's valid for. So timestamp key, that's on the frontline servers. Snapshot and targets keys that actually sign my artifacts, that's potentially going to be on my Jenkins server or my dev laptop or whoever does the release. And then the root key, I'm going to take that, put it on a hardware signing module or a USB drive or print it out if I'm crazy. I'm going to put that in a safe. And I only need to pull that out if I want to make new snapshot or target keys. So I can pretty much keep that tucked away for indefinite until I need to make changes. So Notary, it's an implementation of TUF, and it's actually a fairly opinionated implementation of TUF. And its role is to make it easy to adopt TUF, because slides like this, they honestly simplify TUF, but TUF itself, there's a lot of moving pieces. I didn't really understand it until I read the white paper 2 or 3 times. But Notary is just a very simple interface, and all I have to really worry about as a content publisher is I need to type my passphrase for the signing now. And then as an end user, I don't really need to do a whole lot other than turning on content trust. So it makes all of these concepts be transparently easy to work with and get the advantages from. It's open source. It was announced and open sourced at DockerCon in San Francisco this year. And one important thing to note is that TUF validates the publisher and not the actual safety of the content. So if you come across something that says, I am a botnet, it's probably still a bad idea to run, even if it's from the botnet publisher. So you still have to do some other homework. It's not a guarantee of safety, just a guarantee of origin. So basically, Notary runs a client-server model. So there is a server out running somewhere. And the one for Docker images is hosted by Docker. The Notary signer, it holds just the timestamp key. So in this public implementation of Notary for Docker, that timestamp key is actually held by Docker. So it's essentially a third party. So if they lose the key or it gets compromised, you only have the freshness guarantee compromised, but not the actual origin of the content. So the online key that I have the least control of has the least impact if there's something that goes wrong. So here I am, I'm a content publisher. So I'm going to have my offline root key. And I'm going to also have what Notary calls a tagging key. And they kind of have combined the TUF roles of snapshot and targets into one role. So logically, in Notary's implementation, remember I said it was opinionated, it's a tagging key. So it just uses the same key for both roles. Last I checked, they could have changed it for all I know. So I can, as the content publisher, I can assign other tagging keys to my other developers, and anyone that I want to be allowed to sign data, I can give them a tagging key and keep the root key safe. And then the end users, they can verify my content based on the key that it was signed with. So say I have a tagging key that was compromised. TUF took into account the fact that someone's laptop is going to get left in a taxi or stolen or whatever. With GPG, it can be tricky to reject a key, to invalidate a key that you don't have anymore. So in this case, my tagging key is compromised, but my root key is in my safe. So I take out the root key out of my safe, and I say hey, that tagging key is no longer any good, but I can make another one. And then I would have to re-sign any content that was signed with the compromised key and re-push the signed metadata up. And my users really don't notice any difference at all at that point. So that's really handy. The only thing that the user would see is if the compromised key was used to sign a package that they shouldn't have signed. But once that key is tagged as compromised, if they try and run that content, it'll stop them and say, hey, this is compromised. That's really the only interaction we want the users to have that consume Docker images is there's a problem, content trust kicked in because there's actually a compromise, and that's the only time they should even ever see any such error messages. So that's good. So how do our end users know what our keys are? So the key distribution aspect of this uses a trust on first use model, TOFU, T-O-F-U, trust on first use. So anyone that has ever used SSH has seen the, hey, here's the server's fingerprint, do you trust this? And of course everyone always double checks every digit of the fingerprint and says, yes, I trust it, and then it gets added to your known hosts. And then every time you connect to that server after that, it verifies the key based on what it saw the first time. That's a trust on first use model. So Notary and TUF use the same type of system. We have a little extra protection on the trust on first use in Notary over what the traditional SSH model uses because the public key, the public root key for a repository gets sent over a TLS connection. So the Notary server has a TLS certificate, so you've already kind of verified that this server is who it says it is when you get the public key, and then it's trusted on first use. Where with SSH, it just sends you a public key, and there's no other verification, there's no certificate. So SSH security is pretty good in my book, and I think that the trust on first use model, because of my experience with SSH, definitely works. It's a proven model.
What do you think of the visual key enhancement in SSH as an improvement of that trust on first use model? Does that have any validity?
So the question was, what do I think of the visual key feature for SSH for the trust on first use model? And I actually have that enabled, so I think it's good. I don't know how that would relate to Notary, but I will run it by the Notary team and see what they think, because it's interesting. It's an interesting thought. The only, off the top of my head, Notary and Docker Content Trust in general tries to kind of hide and handle all this for you. So we're relying on things like TLS certificates to provide that rather than the visual model. But I could see some debug output being fun or useful, but I don't think it would enhance too much over what we have with the current model. That's my opinion. And I'd love to bounce that off of the Notary team themselves. So I can do that and get back to you after the presentation if that's okay. So trust on first use, it works, it's good. So first time I see a root key, I'll trust it. So if I'm pulling down the Ubuntu image, I will get the root key that corresponds with that, and then that root key is that root key forever. And if it ever changes, it's going to be a very, very bad time for end users because it's going to look just like an attack. So it's very important to have that root key safe and secure and not compromised. And fortunately, it is easier to have the root key offline with this model than otherwise. So now that we have the ability to sign stuff, how does that relate to Docker itself? There was only a couple hands saying, yes, I used Docker. So Docker's images are basically tarballs. And then, so if I pull down an Ubuntu image, it's going to pull down one tarball for each layer, and it uses a layering file system. So I have a base image, and then I have a layer on top of that. So my layer might be installing Vim or Emacs. So whatever files get installed, I can do a diff and see, hey, these new files are here, and I can take that and make that into a layer on top of the image. So now I take the Ubuntu image, I put the layer on top of it, it resolves the layers, and now I have an Ubuntu with Emacs. So images are just a bunch of layers, and then there's a collection of metadata that says, hey, these are the layers. So we just now need to cryptographically refer to the metadata. So my TUF repository says this image repository has this metadata, and that metadata says, hey, here are these layers, and here are the SHA-256 checksums. So now I can establish, so it's turtles all the way down. If anyone doesn't know that phrase, I didn't the first time I came across these slides. It's a reference to mythology or something like that. So it's talking about Merkle tables. So I have the manifest, and each tree, or Merkle trees, sorry. So each layer has its SHA-256 checksum, and I can have potentially different layers of manifests, and then the parent manifest is what my Notary Docker trust signs. So I have this chain of trust all the way down to the actual files in the tarballs. Does that make sense? All right, I saw one nod, so I'll assume that was a nod for everyone. The way to enable content trust, there's two ways to do it. It's a new feature as of Docker 1.8, which came out, I want to say something like 6 weeks ago, give or take. And it's off by default because it's brand new. And 1.9 actually comes out tomorrow. It's still not enabled in 1.9, but we do want to enable it and have it be the default in the future. So we have this other way to enable content trust down here that says disable content trust equals false. And that's kind of weird, but once we do go to content trust on by default, then there's this flag that's just going to be disable content trust. And that makes sense. So that's why that looks awkward. So let's do a demo. I don't know if the demo gods are going to be pleased or not. So I have a shell here. It happens to be running in a container just to set up my environment. I'm running my own local registry. And a registry is the thing that stores images for Docker. So I'm running one locally instead of using a public one. I'm also running my own Notary server locally, so I'm not pushing up root keys that I can't ever change to the public Notary server. So I can just blow everything away when I'm done. So it's a nice demo setup. So right now I have Docker Content Trust off. So I'm going to do Docker run. And Docker runs is a shortcut for creating and then starting an image. And then --rm says remove the container when it's exited. -it says I'm attaching standard input and I'm allocating a sudo tty. Registry 5000 refers to my local registry server. And then demo is the name of the image. So we'll see if this works. So this is content trust off. So it pulled each layer, downloaded it, untarred the tarballs, created the container, which assembled or mounted the layered file system with each layer. I noticed that there is a digest here. So one of the features added, I think in Docker 1.7, was pulling by digest, and we use that, and that digest refers to the manifest that refers to everything else. So it downloaded the image, ran it, exited. So now that I've run an image, I'm going to do the same thing. Docker content trust equals 1. So now if I do a Docker run, it's going to reach out to the Notary server and try and find trust data. And once it finds that trust data, it'll try and pull the corresponding image by SHA rather than by this name that's kind of loosely defined. So this just failed because I haven't actually published any metadata. So since I happen to also control this registry and I'm the content publisher for this image, let's push that now. So Docker push registry :5000/demo. So this is the normal interface for pushing images. Normally when I push an image without content trust, it just goes. Since this is the first time I'm pushing, it's going to prompt me for a passphrase for my root key. So I'm creating a root key, and then it'll ask me for a passphrase for my targets key. It'll create that, it'll sign the content with that, and then push everything up to the registry and to the Notary server. No tag specified. So one of the things in Docker is this here, registry :5000/demo. That is the name of an image. And without content trust, I tend to push images without :latest, and it's implied. But content trust, they decided that they didn't want any implicit behavior when signing and pushing metadata. So I have to explicitly add :latest on, or if I had another tag, like I could call it v2 if I had such a tag. I don't though. So now I'm going to push it explicitly with a tag, so that's the fully qualified name for this image. So I'm creating the root key. And now I've created a tagging key, except they call it repository key for some reason here. And my root key has signed my tagging key, and it tagged and pushed everything. So now I have content trust available. So let's go back to this run. So it's the same command, but content trust enabled with trust data available. So here we go. It found unable to find image, download a newer image, and there it's pulling it by SHA, and then it tagged this long fancy SHA name to the :latest name that's implied, and then ran my application. So I've just done content trust live demo. Thank you, demo gods. But what if someone hacks my registry? So I'm gonna shell into my registry. So for those of you that aren't familiar, I'm running my registry as another container, and the docker exec command tells me, hey, run this other process in this existing container. So if I do exec bash with standard in and sudo tty allocated, I'll get an interactive bash shell in this running container. So now I'm the hacker, I'm the red team, and I'm going to go ahead and hack this demo application. So it's hacked. So what I've just done is I have swapped the manifest for this repository with a repository that runs some code that is kind of malicious. So now that I'm hacked, I'm going to exit the shell from the registry, and if I run this, what's going to happen is it's going to get the content trust data down from the Notary server. Since I have already pulled this image that has valid content, it's just going to use what's here locally. So it's actually just going to work. So that's kind of cool. I've just hijacked this repository, but since I have a local copy, I'm saved already by content trust. If I turn content trust off, and then I run it, it does no checks. It just uses what is already local. So I'm also saved a little bit. But if I do a docker pull on registry :5000/demo, it just downloaded the malicious image. So now that if I run it, I've been hacked. So now let's turn content trust back on and try it one more time. Boom, I'm running the right thing still. So content trust, it's actually kind of hard to break it. So actually let's do a poll with Content Trust enabled and see what it does. All right, it saw that I am up to date, so it isn't trying it. So I'm actually going to remove this image so I can try and actually pull it. Docker RMI registry :5000/demo. So I'm removing this image from my local cache of images. I've got a question in the back. SHA-256? Oh, this image is just a bunch of echoes that are colorful. So my demo is just, it's not a real application. So that when I Docker run something, it can be anything. And for this demo, Diogo Monica, I believe, is the one who put it together. He's the security specialist at Docker. He just did that so it was colorful and looked all hackery. I think he's behind the train as well. The what? Yeah, it's just a bunch of gibberish. Sorry. So I'm going to go ahead and remove this image, and hopefully it's really gone. Actually, I'm going to do a heavy-handed thing. Docker images -aq xargs docker RMI. So I'm deleting any image that's not in use, basically, and it's failing on the ones that are. And I have so many images because each layer has its own ID. So now I'm going to try and pull. I shouldn't have the image locally, and it's the hacked image on the registry, and I have Content Trust enabled. So we should see. Interesting. Yeah, it pulls it by SHA, so it still saves me from the attack. So I can't. Docker Content Trust is tricky to break. So now if I run, I still have the correct image. So that's just the manifest. So Content Trust basically gives me a pointer to the real manifest no matter what I do. So that's really nice. So what happens if I tamper with a layer though? Because I can definitely do that. So I'm going to Docker exec back in to my registry, and then what's the fun command? They made up a command. There we go. So this location on the file system is one of the layers in this image. So if I do something malicious, I've just altered this layer without Content Trust. I guess I'd have this extra thing in my layer, and that could potentially be malicious. This is just breaking the hashing checksums for right now, though. So I'm going to go ahead and get out, and I'm going to try and do a pull. Oh, I have to do the image removal again. There we go. So I've just tried to tamper with a layer, file system layer verification failed for digest, blah, 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 blah. So now I can be sure that my images are not tampered with. The timestamp role is working its magic in the background, so I can be sure that the manifest I'm being fed when I do a pull or a run is correct. That is my demo for layer tampering. Notary also has its own command line tool. I don't have a demo set up for it, but you can do fancy things with your Notary repository if you use the command line client. So it's a separate tool that you install alongside Docker. So if I need to do key rotation or delete tags out of the repository or stuff like that, I'm going to be using the Notary command line tool. There is a bit of a roadmap. It's still being developed and features being added. The base use case, of course, works. We just tried it. We have images that can be signed. I can verify that they came from where they said they came from. Docker's official images are also signed, so when I Docker run Ubuntu or Nginx or MySQL or any of the official images, I can have content trust enabled, and that's really nice. Calling all devs, if anyone knows Go or wants to learn Go and is interested in TUF Notary, they are accepting pull requests. And Docker-trust on Freenode is where the Notary and Trust team folks hang out. So any other questions?
Sounds like you intend for this to distribute a wide variety of content, not just software, like a news site might use this to show collections of news site and verify that the article came from the actual office.
Yeah, the question was, it looks like this could be applied to things other than Docker images. It could be used for non-software content, even possibly news articles from a news source. So that was the question. The answer is yes, absolutely. Notary could be used to sign any sort of content. The demo they did when they announced Notary was actually signing a bash script talking about the curl pipe pattern that we see in our industry. You can actually do a curl pipe to Notary, pipe to bash, and then if it gets tampered with, it will stop. And that I really enjoyed watching that demo that the Notary team did when it was brand new, because curl pipe to bash is something that's not very well liked but very prevalent right now. When Diogo did it, when he tampered with the bash script, he actually put as the install.sh was rm-rf/, and he did it live, and it worked. So he followed two demos that didn't go so well, so he was nervous. But yes, absolutely, Notary can be used to sign your vacation pictures or whatever. Any non-content trust questions, or it doesn't have to be Notary, it can be anything Docker since I'm here. Sure. Okay. So the question was, has there been any progress, or what are best practices around managing secrets in Docker? And the answer to that is yes and no. You can use any secret distribution mechanism that makes sense. Docker is a high enough level tool that doesn't lock you into one thing. That's a good and bad thing, because it's nice when there's like one holy grail way to do something, and that's the obvious best practice. But with my experience with other tools like Chef, even the best practices, they change so quickly. I will point out the fact that Docker 1.9 that is coming out tomorrow has the Docker volume subcommand. So volumes are now first-class citizens, so you could potentially manage your secrets in volumes, and since they're not this ephemeral kind of weird, weak presence of statefulness, and they're a little more, they're now first-class citizens, I guess. It might be more savory of a solution to use volumes and just stuff your secrets in volumes. Personally, I'm a fan of using volumes like SSL certificates. If I'm running an SSL certificate, I'm going to fire up a container and I'm going to put that in a volume. And that volume is probably just going to be a directory on the host, and then I deal with getting that up there with SSH or whatever other, like I could use pass with GPG and Git and decrypt it as I deploy and do all that stuff. So, yeah, I'm a big fan of pass, and there's no reason you can't do that with Docker, because you can run anything in Docker. So, well, I'll go ahead and end if there are no other questions. Going once, going twice. All right, sold. Thanks for coming, everyone. I appreciate it.